testing. So hypothesis testing is really at the core of any statistical analysis that you'll do. And what do we mean by a statistical hypothesis? Well, it's just an assumption about a population parameter, for example, the population mean. So we will get a sample mean from our sample, and we want to infer something about the population mean. Because remember, we're not really that interested in the sample, but we're interested in what the sample can tell us about the more general population. So hypothesis testing just refers to the formal procedures that are used to evaluate statistical hypotheses. So let's look at an example. And let's say we want to test whether the average age of female slaves in 1800 in the Louisiana database on slaves is significantly different from 21. Right? Now, the sample mean in that particular database is 22.3, but that does not imply that the population mean is different from 21, because that difference could just be due to sample variation. Remember, we only get a sample of people in that database. We don't have the full population. And so that's why we need to formally test the hypothesis. Is that 22.3 compatible with a population mean of 21? So if in the sample we see 22.3, could it be the case that actually for the general population that we're interested in, the population mean is 21? So how can we do that? Well, we first need to state the null hypothesis, H naught, and we're going to say that H naught is mu age is equal to 21. Okay, that's what we're trying to test. So we're going to see whether there's some evidence to disprove the fact that the population mean is 21. And the alternative hypothesis is just the conclusion that we will draw if we reject the null hypothesis. So in this case, the alternative hypothesis, which we denote as H1, is that mu age is different from 21. Okay, so whenever you want to test a hypothesis, you start with a null hypothesis, and then you take the negation of your null hypothesis, and that will give you your alternative hypothesis. The next step is to actually calculate the test statistic, assuming that the null hypothesis is true. Okay, we always assume that the null hypothesis is true, and we'll see what that leads us to. Okay, so thanks to the central limit theorem, we know that under the null, that means assuming that the null hypothesis is true, that the sample mean, x bar age, will be approximately distributed normally with mean mu age and variance sigma squared age divided by n. That's what we saw in the last video. Now, if we put in the values that we were looking at in our hypothesis, that means that the sample mean x bar age is distributed normally with mean 21, because remember 21 is what we assume in our null hypothesis. And then the variance, we're going to say it's 14.94 squared. So that actually is the sample variance. But here, for the sake of today's video, we'll assume that we know the true value of sigma age, and that the true value of the standard deviation of age is 14.94, which actually is the sample standard deviation. This is an approximation, but it works really well here, and we'll look into that in a later video. So for the moment, let's just assume that this is just the true value of sigma age and divided by our sample size, which is 552 here. Okay, so assuming that the null hypothesis is true, we know that this should be true. Now, what we can do is to plot a normal distribution with a mean of 21 and a standard deviation of 14.94 divided by square root of 552. And then we can just calculate the probability that the sample mean would be at least 22.3 minus 21. That means 1.3 units away from 21, okay? Which would be this area in blue. So all of this area and all of this area, okay? And the idea behind this is that we want to see how likely is it that we would get an outcome that is more extreme than the one we got, okay? Remember, we got 22.3. So what is the probability that we would get something more extreme? That means like further away from the population mean than 1.3 units. So in this direction, that would be being above 22.3. And in the other direction, that would be being below 19.7. Okay. So in this case, we're looking at both directions. Okay. And so what we need to do is just calculate that area in blue. And if we do that, we will find that the area in blue is equal to 0.0388. That means that this area corresponds to 3.88%, right? And that will be the probability that the sample mean would be at least 1.3 units away from 21 if the true population mean was 21, okay? And we'll call that probability the p-value. The next step in our hypothesis testing is to set the significance level for the test, which is the maximum p-value needed to reject the null hypothesis. So that's something that you can set yourself, but in practice, the p-value is often set at 5% or 1%. And if the p-value is below alpha, so below the significance level, we reject the null hypothesis. And otherwise, we fail to reject the null hypothesis. Okay, so always remember, if the p-value is below alpha, we reject the null hypothesis, and otherwise we don't reject the null hypothesis. And one of the very, very important thing to remember is that if the p-value is above alpha, we fail to reject the null hypothesis. We never accept the null hypothesis. Okay, that's super, super important, and that's a very, very common mistake to make. We do not accept the null hypothesis. Okay, basically, the procedure of testing a null hypothesis is very often trying to find enough evidence to disprove the null hypothesis. But if we don't have enough evidence to disprove it, we can't just conclude that the null hypothesis is true. We just don't have enough evidence. So let's think about the previous example. So we had a p-value of 0.0388. So if, let's say, we have a 5% significance level, then what do we say? Well, this is clearly less than 0.05. So in that case, we would reject the null hypothesis because it is below the significance level. But now, let's say that instead of 0.05, we took 1% as our significance level. Well, here we can see that 0.0388 is actually greater than 0.01. So in this case, we would fail to reject the null, okay? So the smaller the significance level that you pick, the harder it is to reject the null hypothesis. That means you need more evidence that the sample mean that you obtain is incompatible with the population mean that you hypothesized in order to reject the null hypothesis. So let's do a quick recap on the different steps that are needed to test a hypothesis. So you always need to start by stating the null hypothesis and the alternative hypothesis. Then you calculate the test statistic, assuming that the null hypothesis is true. And then using the known distribution of the test statistic under the null hypothesis, you calculate the p-value. You set the significance level alpha for the test, and then if the p-value is below alpha, you reject the null hypothesis, and otherwise you cannot reject the null hypothesis. So that's it for today's video, and I look forward to seeing you in the next one.